Hello, everyone. We'll be starting with the session. Hello, everyone. Good morning, good evening, good afternoon. Dear authors and invited guests, welcome to the technical session 40. Myself, Anshika Jain, and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The 9th edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th of February 2024, and the virtual event is being held through the Zoom today and tomorrow, that is 21st and 22nd February 2024. I hope you will enjoy the knowledgeable and interactive session throughout the day. Coming to the guidelines, in this session, we have 6 presentations, and each presenter would be given 12 minutes for the presentation and 2 minutes for the question and answering. There is another request to all the participants that you all stay connected with us through the closing remarks. If you have any query or any update, you can write it to me in the chat box below. Just before we get started, I would like to introduce the chair for the session. We have Professor Caleb with us. He's an assistant professor, an experienced researcher with a demonstrated history of working in HPC projects, skilled in high-level and low-level parallelization using multi-threaded development and distributed systems, C, C++, and Java languages. Welcome to the session, sir. Would you like to share a quick opening remark with us?
Thank you for the introduction. It's a pleasure to me to be here on ICICT conference here, being a session chair for such a conference. I hope I will help you people here, not only talking about the conference papers presented here, but also in the future, if you have any questions about HPC and or what we do here in Brazil, it would be a pleasure to me to explain. Thank you.
Thank you so much, sir. So we'll be starting with the presentations now. So first, we have Justine to present his paper titled Assessing the Security and Privacy Implications of File Sharing Applications. Are you there, sir?
Yes, I'm here.
Okay, sir, you may start with your presentation. Yeah,
Can you see my
your
screen?
screen is visible.
Okay. Good day to you all. I am Justin Paul Ernie, a student from Mapo University. I'm presenting our case, Assessing the Security and Privacy Implications of Mobile File Sharing Applications. We will cover the objectives of the study, scope, limitations, methodology, results, key findings and recommendations, and conclusions of our case study. File sharing systems have greatly expanded and are now a frequent component of society's day-to-day activities in the digital world. These platforms redefine communication between individuals and organizations by simplifying network file exchange. Additionally, file sharing systems possible security risks and vulnerabilities must be investigated to know the cause and how to mitigate such risks when sharing files publicly or privately. Furthermore, the file sharing systems must be able to guarantee users of these systems that always follow the laws and policies regarding data protection. In addition, it must safeguard all digital attacks possible through file sharing. For our objectives, we will evaluate the security of file sharing applications that we chose. Then we will identify vulnerabilities and compare the applications based on their number of vulnerabilities. This study will mainly focus on assessing vulnerabilities of 3 file sharing applications available in the market. The study will also analyze the 3 applications to understand better which could have mitigated such risks and those with many vulnerabilities. The study will be limited to only 3 mobile applications, and the study will only focus on Android applications. Moreover, it will only use the latest versions of the file sharing applications. And furthermore, the researchers will provide solutions and recommendations based on the gathered information from the MOB SF conducted on the 3 file sharing applications that will be studied. So for our review of related literature, exchanging one or more computer files through a network with a relative, colleague, or a friend abroad can be referred to as file sharing. The file sharing system works to transfer files. It needs a network directly between the 2 computers, or it can be a server to a computer. The file being exchanged between a server and the computer will be transferred to a storage area of the server where it can be accessed and shared by other people. Moreover, file sharing can be accessed anywhere, anytime, and in which the file can be downloaded from that specific server. The file sharing system can be shared publicly or privately by sharing the folders or files. In addition to that, the file sharing system must be able to connect its computer to a network to be able to work. Various users can access the identical file because of the file sharing system capabilities. Privilege and access rights may depend on how the users can share their files, where several users can only read access files or folders, while some users can generate or alter the files or folders. The file sharing can be obtained through server message block, which Windows commonly supports. The resilient file system is made by Windows and shared by the admin, where the files or folders are readily available through the SMB protocol. The file sharing in the operating system may vary from various operating systems. Thus, some operating systems may have better features or functionalities for this. User rights and storage restrictions may limit the data a user may store in a shared folder. Peer-to-peer file sharing utilizes consumer-level system wherein each user's computer servers as a client in much more extensive file sharing network. When a user downloads files from this network, the peer-to-peer software locates the location of the data and then streamlines the download operation. Peer-to-peer networks have a reputation for being mostly utilized for sharing pirated media, although they have also genuine uses. Exchanging one or more computer files to a network with a relative, colleague, or friend abroad can be called file sharing. In this vulnerability assessment, the researchers selected 3 prominent file sharing Android applications to evaluate their security posture comprehensively. So for our methodology, first step involved carefully selecting 3 applications, ensuring they represent various file sharing functionalities commonly used by Android users. The researchers employed the black box testing approach utilizing Mobile Security Framework or MOB-SF to assess the security vulnerabilities. This sophisticated tool enabled the researchers to analyze the applications without any knowledge of their internal structures, providing a perspective like that of an external user. MOB-SF, a robust and versatile security assessment tool, performed in-depth analysis, identified potential vulnerabilities, and evaluated applications against various security standards and best practices. Our team searched extensively for common vulnerabilities, exposures, or CVE reports to validate further and cross-reference our findings. This step aimed to establish correlations between the vulnerabilities detected through the MOB-SF scanning and known security issues documented in CVE reports. The cross-referencing process was meticulous, involving a detailed examination of CVE databases and related resources. Displayed on the screen is the UI of MOB-SF. It is a simple drag and drop static analyzer for mobile applications. How MOB-SF works is pretty simple. you submit an IPA or an APK for the software to statically analyze the app by decompiling it, file extraction, then analysis. It will then create a report of the findings once done. So for our results and key findings, the first file sharing application is a well-known file sharing application released in early 2010s, now with over 100 million downloads. This file sharing app initially gained widespread popularity due to its exceptional features that surpassed those of pre-installed file managers offered by vendors. However, its trajectory shifted as it later transformed into an adware. The comprehensive security assessment, represented by its latest version, underwent a rigorous examination using the advanced capabilities of MobSF. MobSF, with its robust capabilities, provided us with invaluable insights into the application's security posture. So for our results, app number 1 showed a score of 21 out of 100 and a grade of F. Based on the MobSF scoring system, this application poses critical risk, and 7 trackers out of 428 scanned was labeled as risks. For the next app, 103 vulnerabilities were scanned, 58 are high risk, and 45 are medium risk. For the vulnerabilities, it was reported to have high risk and medium risk permissions. It was also reported to have insecure configurations, such as clear traffic that can be exposed and ones that are commonly found in apps, user installed certificates, and trust system certificates. So this application was created in 2013, where it is a peer-to-peer file sharing application at that time of the release. However, after numerous updates and advancement in technology, mobile application number 2 is now a well-known file sharing application that offers cross-platform capabilities, which provides users with easy and quicker transfers of file between devices. Moreover, it also provides numerous formats of files that can be shared. It is also known to have capabilities that transfers in high speed, which is a tool for convenience and large file sharing. Additionally, it also utilizes the need for Wi-Fi Direct and Hotspot, where it will be the main process of file sharing application, in which it will be able to establish a direct connection between the devices during file sharing, as well as providing security, which ensures that it is efficient and has transfers that are fast. Lastly, this file sharing application is being used generally by most people because it offers the efficiency and the convenience of sharing files between devices, where it is a preferred application by people and companies that requires data transfers which are quick and secure. However, app number 2 shows a low grade of 23 out of 100, which is considered critical risk, and a grade of F with 12 trackers out of 428 are considered risky. There were 340 vulnerabilities found. 183 of them are high risk, and 157 of them are medium risk. Vulnerabilities shows permissions, manifest report, and network insecurity. On the config of the app, as mentioned, there was an insecurity in the network as it was reported to permit clear text traffic. The third mobile file sharing application is an app that allows users to control their Android devices from any Windows
Sorry to
operating
interrupt, sir.
system.
Sorry to
Okay,
interrupt, sir, but you have 2 minutes to conclude your presentation.
okay. Uh, this application is a useful tool wherein users can share their files, such as photos, songs, and even videos to any computers, or vice versa. There are 131 vulnerabilities found on the third file sharing application, wherein 106 of them are at high risk, while 25 of them are considered as medium risk. There are vulnerabilities that we scanned, and these are about the application permissions, which are between high and medium risk. Base configuration was also gathered, such as the clear text traffic, user installed certificates, and the trust system certificates. For our recommendations, we recommend enhancing encryption methods, conduction of regular security audits, and timely patches of vulnerabilities. Continuous monitoring will also help to detect and respond to security threats in real time, and regular updates to address the vulnerabilities and issues with the app. So this is a quick rundown of our uh, results. This study examined 3 file sharing applications to determine the security ratings and weakness. In one case, according to MobSF, mobile application number 3 may have the second most vulnerabilities. Still, it was the most unsafe application among the 3 applications because of having an application security score of 9 out of 100, which is in the range of a common vulnerability scoring system at the critical risk. Application number 2 is the application which has the highest number of vulnerabilities, and mobile application number 1 had the lowest number of vulnerabilities out of the 2 mobile file sharing applications. The 4 application components, namely activities, broadcast receivers, services, and content providers, have the most vulnerabilities. This means that components of the application are found to be at risk of vulnerabilities of being at the critical severity or medium severity. It also shows that the network security applications of the 3 file sharing apps had insecurely configured based configurations and domain configurations that are found to be at high risk and medium risk, wherein some configs are formatted in clear text. User installed certificates are permitted as well as system certificates. Lastly, the case study and its investigation of the 3 mobile file sharing application reports underlined the need for security audits and continued attention to mobile file sharing applications. Thank you.
Thank you so much, sir, for your presentation. Questions? Any questions, sir?
I am a little bit curious about these 3 applications, those 3 applications. How did you chosen then? It was based on some store ranking by the users or ranking by downloads. Sorry if I missed this information.
These 3 applications are the 3 most popular file sharing apps that we found on Google Play. So we thought that
Okay.
it would be great to test the security of the apps.
Yeah, it's interesting. The most popular is similar to the most downloaded apps on that store. Is that?
Yes.
Okay. Okay. I'm a bit curious too. There is any other paper or even on site that we can find some information about those vulnerabilities, ranking those worst and classifications about that, or you couldn't find any other paper or even site about that?
We didn't find much paper about rankings, specifically on file sharing applications, but more on applications that are notorious to be pretending to be legitimate, but is secretly an adware or something risky like that.
Okay. Okay. Very interesting. Thank you for your presentation.
Thank you. Thank you for all your time.
Thank you so much, sir, for your presentation. So now we'll be moving on to the next presentation. We have Kola to present her paper titled Blockchain Technologies for Transparency in FinTech. Are you there, ma'am?
Hello. Hello. Yes, I'm here. Hi.
Hello, ma'am.
Hello, everyone. Yeah, so I'm sharing my screen.
Hello.
Yes, ma'am. You may start with your presentation.
Okay. Okay. Is it visible now?
Yes, ma'am. Your screen is visible now.
Okay, good. Okay, so let's start. Okay, hello everyone again. So today I will present my work about blockchain technologies for transparency in fintech. So I am Khawla, I'm professor assistant at Alta University in Budapest, and I will present my work with my supervisor Balint Molnar and my student Majid. Okay, so this is the plan we will follow. So we will start with an introduction, the goals of our paper or of our work, overview of a fintech, blockchain definition and history. We will as well define the role of transparency in fintech, methodologies and tools used for our project, the project functionalities and project structure, and we will conclude our work in a conclusion. Okay, so blockchain technology has a potential to improve transparency in fintech, in financial industry, particularly accounting, auditing, and supply chain management within fintech. And generally, fintech is defined as the integration of technology in financial services. So this is just a simple definition of fintech, and it has like an impact on both society and economy. So this is like okay, so it have as well an impact on financial services, and this evolution is with related more with various technologies, including cloud computing, blockchain, and artificial intelligence. So the main goal of this paper is to investigate the use of blockchain technologies. We will focus more on transparency technology in fintech, and we will focus as well, on advantages and the challenges in implementing blockchain for financial process, including accounting, auditing, and supply chain management. Okay, transparency as well in fintech is critical, and it helps customers to understand the financial products and services, and they are services, including fee, terms, and conditions. So about the main goal, it will be like a case study of blockchain based on financial platform, examining its impact on transparency and accountability. So it's as well will more investigate how blockchain solutions could enhance transparency in payment, loans, and assurance industries. Okay, so here we have just a simple overview about fintech. Generally, fintech is defined, or financial technologies is encompasses of the use of technologies and automated financial services and processes aiming to improve accessibility, speed, and cost efficiency. It includes as well innovations in personal and commercial finance. As well, we have here transparency is have like an important goal in building stakeholders' trust, and a lot of challenges behind the transparency, such as concerns related to data privacy, cybersecurity, and legal compliance. So we move now to just a simple introduction about blockchain. So generally, the idea of blockchain is originally in the late of 1980 and early 1990. So considering various references, we can define or describe blockchain as a digital ledger forming a chain individual data blocks with the new data regularly added. A new block is formed and added to the chain. So this is just a simple introduction or simple definition of blockchain, but we have several definitions related with blockchain. Okay. So generally we have distributed ledger in one of the is one of the fundamental characteristics of blockchain, and it's referred to generally databases or database that consequently shared synchronized across multiple sites. And we have as well immobility. So and we have a conscious mechanisms, a mechanism which enable agreements on the validity of transaction within a distributed network. Okay, so here we have some related works where we can apply different blockchain technologies on fintech, and some other works are described the relation between fintech and a blockchain. So here, this is just small part, or like here we have only small number of references, but in the paper is more than ones I mentioned here. So we have different references, and in conclusion, the integration of blockchain technology in fintech has the potential to enhance transparency, and we have as well other works which are more related with transparency and other technologies as well. So transparency in fintech refers to customer ability to easily comprehend and access information about the financial product and services they use. So generally, this is the transparency in fintech, and how can we ensure this transparency? So generally, transparency is an aspect of blockchain technology, and generally it's maintained by decentralized network of computers, and ensure the accuracy of information which cannot be altered or deleted. So we mean like it will be more okay. So during our work, we use a lot of tools and applications. So this is only some of them because we already use a lot of tools. So as examples, we use JavaScript, React.js, Node.js, digital signatures, and other tools related as well with blockchain. Sorry. Okay, so here for Node.js, so it's an open source class platform, server-side runtime environment for JavaScript. So here it's enable programmers generally to create online applications and escalate the platform. So this is used during our application to create the application and the different chains and blocks used. React.js as well, which is an open source of JavaScript, is used to building user interfaces. We used as well a lot of blockchain principles like blockchain, wallet, cryptocurrency transactions, and transparency. So those are the different technologies used during our work as well to create different blocks chain, and to create the different transactions. Okay, so those are the different steps of our project to create the different functionalities. So the first step is to conduct transactions and encourage users to offer in a simple and safe transaction interface. And after that, we make our transaction, create different blocks, and after that, we checked if the transactions are valid or not. Okay, here's there is some functionalities. So the first one is contract transaction, where users can initiate transactions by narrating the recipient's wallet address and transfer amount and the associated fees end user in the interface. So before generally the transaction is products. So the blockchain in the blockchain network, so users can preview the transaction details and confirm using this component. So here as well we have this is like a transaction, and how can we confirm if this is like the interface used for transactions to create our transactions. And after that we have, this is the structure of the block that we used in our application.
Sorry to interrupt, ma'am.
And here,
Sorry to interrupt, ma'am, but you have 2 minutes.
sorry.
Sorry to interrupt you, ma'am, but you have 2 minutes to complete
Okay.
the presentation.
Okay. All right. Okay. Okay. I will try to finish in time. Okay. Okay, so this is the project structure, and the block structure, where we have different parameters to create our blocks. And here as well we use transactions, and after that each transaction should be verified, and we will confirm if it's like a valid transaction or not. And this is where we're generally based on transparency. So here, if the transaction is valid, we can continue and guarantee that the transaction is in the final and has been verified by numerous networks node. So generally, if the transaction is verified, so we can confirm if the block is added to the blockchain or not. Okay, as a conclusion, so we will try in our paper just to improve or investigate the importance of transparency or blockchain technologies in general in fintech sector. And as future work, so till now we are still working on this project, and a lot of use cases will be used. We are like a group of fintech lab. We are trying to use the different blockchain technologies and making some use cases projects. Till now, this project is 80%. We still don't have a lot of results, but we are trying to do our best in this month to finalize everything in time. Okay, here is some references, and thank you. If you have any questions.
Thank you so much for your presentation, ma'am. So any questions?
May I ask you a question?
Yes, of course.
I worked a little bit with Bitcoin, and one of the most known problem of that, not on Bitcoin, but also blockchain in general, is that the amount of the measurement of transaction per second is not so high, similar to regular transaction. Have you addressed this problem yet, or are you planning to figure it out in the future?
Yeah, so this what we are working on generally. You know, that's a bit hard to work on that kind of transactions. So we are trying to do our best to work on it. Yeah.
Okay.
So we are still working on it.
Okay. I'm talking about that because here in Brazil, we are a huge country, and it's not so easy to implement blockchain financial or even in a fintech, because we have a lot of transaction per second here,
Yeah.
and people are not so happy with this kind of technology here at all. We are talking about using this kind of technology to improve some kind of baseline in some parts of the road transaction. But I'm only interested to know if you have things to say about that. Okay, thank you.
Thank you so much. Thank you. Any other questions?
Thank you so much, ma'am, for your presentation. So
Thank you.
to the next presentation. Next, we have the next presentation to presenter to present his paper on the title Dimensional Reduction to Improve Learning Recommender Systems, Precision Based on Grades. Are you there, sir? Sir, are you there? Okay, I guess, yeah, sorry, sir. So you're not audible to us? Hmm. Okay, until sir is ready, we'll move on to the next presentation. So for the next presentation, we have EE to present his paper titled Effects of Inductive Load on Photovoltaic Systems. Are you there, sir?
Yes, I'm here.
Okay, sir, you may start with your presentation.
Right. Okay. Can I go ahead? Okay. Oh, my screen is seen.
I think there is a problem.
Okay. Is it there now?
Yeah, we can share.
Is it seen now?
Yeah, we can see that you have started sharing the screen. So,
Okay. I think it's fine now. Can I go ahead now?
so, but we are not able to see your presentation. Yeah, now.
I've shared it down.
Yeah, sir.
Okay.
Okay, sir. You can go ahead.
It's there now. Okay. Okay. Effect of inductive load on photovoltaic system. That is the PV system. The paper is authored by myself, they call Okpo, Pedley Rogues, and Ogbona Okoro. The paper will be presented under these subheadings: Introduction, Literature Review, Methodology, Results, and Discussion, and then Conclusion. Introduction. The advent of technology in recent times has driven a surge energy demand across sectors, including industrial sectors and commercial sectors. Of course, we have so much demand, mostly in Africa, of electrical energy, which we cannot satisfy the customer, the consumers. The negative environmental effects that is combustion engine imposed on the environment cannot be overemphasized. Of course, pollution here and there, these are the things that we face every day, and it leads to some health challenges. Therefore, the research needs to comprehensively examine the effect of inductive load on the PV system and propose potential mitigation strategies to address the challenges. Of course, here we are looking at the effect of the inductive load on the PV system because that's the greatest challenge. The greatest challenge is the inductive load due to the high demand at starting of the motor, high demand of power at starting of the motor. And then in all, the sources of renewable energy, solar PV is seen to be the most available and simple to use. In Africa, of course, the sun is always very high. The temperature is always hot, unlike some Western world. So we have the high potential of this renewable energy source, which is the solar, to provide a much needed electricity. The review was made under the studies on a comparison between the predicted between the predicted transient torque and speed in a conventional model of a three-phase induction motor did a study on that. Then inverter-based grid system, though it has existed for several decades, a controversy regarding their reliability when it becomes the dominant source compared to conventional source. Yes, we may say inverter-based grid, but what if it dominates the grid, and then will it be able to serve the inductive load and other very challenging load and stubborn load? So that is what we have also looking at here. The high demand associated with inductive load are a crucial element in power system that significantly influences the distribution network and overall performance and efficiency of PV when deployed to save such load. Yes, because the reactive power, which always come in to mitigate the effect of this inductive load, is not seen to be visible in a solar PV system. So there is a source of worry there. Then the methodology. How did we do this? First, we look at the sizing of the PV array, the solar panels, and how many do we need to be able to get what we want. And then we also look at the modeling of the inverter system. We also look at the modeling of the asynchronous motor, that's the inductive load. How do we bring it in the grid? How do we bring it in the model? And then we also look at the PV system interface with this inductive load as the synchronous machine. And then this was done in MATLAB. We used MATLAB to model this. And of course, the model we are seeing here is that of the PV array. We look at how many panels will be there to be able to sustain the load and give the needed capacity. The needed capacity here was between 25 kilowatts and 20 kilowatts, between 20 and 25 kilowatts, because the load used is 15 and 7.5 kilowatt to really test and see the effects of the inductive load. Then we also look at the inverter simulation model, because we know that this PV, when you get the needed resource, and then you must invert it at the end of the day to be able to have an alternating power so that it can drive the inductive load, which is alternating load. So we also look at the modeling. Of course, these are the legs, the inverter, and then we also have some blocks here which we use to incorporate the load, which we've seen in the other model. Then we also look at how do we now bring the whole thing together. This is the complete model of the solar panel, the array that was sized. Of course, it supplies through here to the system, and then it's feeding the inductive load, which is here. The inductive load is here, and then is also outputting. So this is the inductive load, which is the asynchronous machine, the inductive machine that is being tested, on this solar PV system. So we have the result. I do not have much text, but I think I will use the graphic to explain the result. First, we look at the three-phase rotor current of the asynchronous machine rated at 15 kilowatts, and then side by side with that of a three-phase rotor current of the asynchronous machine rated at 7.5 kilowatts. Of course, we can see the transient. The transient is very demanding, and it's worrisome because the load is high here, and then you can see the ripples on engaging the load at 1 second, and then it moves 2 seconds intermittently and 3 seconds intermittently. The same thing happens here. At 1 second, it is engaged. Of course, we can look at the transient first. Look at the transient to find out that it's not much. Of course, this capacity can best fit the load and with less ripples so that it can drive it well. And of course, we can see side by side that the 7.5 kilowatt is performing better, though the load is still being driven, even at 15 kilowatts. So the bone of contention here is just to try and show the effect of inductive load on this solar PV of the same capacity. Both loads are driven by the capacity. Now we can see the intermittent loading, the first 1 second here, 2 seconds here, 3 seconds here, and then 4 here. Then the next one, this is the 3-phase rotor current of the synchronous machine at 50 kilowatts, and this one is at 7.5 kilowatts. Then the next one we have the rotor electromagnetic torque of the asynchronous machine. Of course, the torque, it drives the load. We can see at 15 kilowatt, we can see the rise to be able to wheel the load. And of course, the ripples. Then intermittently at 2 seconds, we can see, and then it goes down like that to down till 4 seconds. Then of course, coming also to the 7.5 kilowatts here, you see at 1 seconds, it pushes up, but not that troubling. Of course, the ripples is not much, and then it moves to 2 seconds and 3 seconds, and of course here. Of course, well, let's go back to the transient. We can see the transient, though rising here, but not that troubling. Of course, it rises to 20 newton per meter here. One is not that close to 20 newton per meter, of course. It's not that close to 20 newton per meter, but this one is very close to 20 newton per meter. So it rises, and then the general comparison shows that it performs better at this less load than the load that is near capacity of the inverter, that's the PV system. Then we also have another characteristic that was measured and compared is the rotor speed of the asynchronous motor rated at 15 kilowatt. Of course, the speed, we can see the speed it moves. Of course, the ripples is very high here before it can come down, and it raises again at intermittent loading, and it moves again at intermittent loading. But here is also high, but the ripples is not much, meaning that it's comfortably driving the load. Then we also look at the transient. The transient, it is high here, but here it's not that much. So it drives gently before it begins to, you can see the effect of the inductive load. You can see the effect of the inductive load. So these are the 3 characteristics of loads. Inductive load that we measure. And at the end of the day, it is discovered that the lesser load is more economical to be driven. Of course, that shows us that we need much investment on this solar PV system so that we can be able to integrate it fully into the inertial aspect of it, because the synchronous machine, the conventional power source, which is driven by the synchronous machine, has inertia. Then the PV system does not have inertia, so used to drive a load. Of course, we can see. So that is what was looked at. Then, in conclusion and recommendation, of course, we have seen in the rotor current, electromagnetic torque, rotor speed, the PV source is greatly impacted as it is loaded intermittently at 1 second, 2 seconds, 3 seconds, and 4 seconds. And the responses are observed due to load variation. Now, also the study's outcome showed that the significant improvement in the machine stability is recorded when the synchronous machine rated at 15 was replaced by that of a 7.5 machine, while maintaining the same power supply from the PV system. Yes, which is what we have designed at the end, at the early stage. Now, huge investment is imperative in this enabling sector to conveniently power inductive load as it pays off in the long run. Now, we can go back again and look at what we are saying. Now, we can see that the capacity used in this study is between 20 kilowatts and 25, but the load driven is 15 kilowatts and 7.5 kilowatts. And then the comparison are made. And of course, we have seen that there is less stress if the less load is used. And then, so that tells us that we need a very high capacity of a solar PV system, mostly when inductive loads are to be used. Because inductive load, all these machines in the industries, the lifts, the fans, the chillers, the fridges, and these are inductive loads, which require a lot of power, capacity, high capacity to be able to drive. And if it is not synchronous, of course, the source does not have the inertia that would support, and of course, the reactive power too. It may be a very serious issue. So the study was done to look at the effect of inductive load. Supposing we have a grid that does not have any synchronous or conventional system that supports it, is purely a PV system, then how are we going to invest to be able to drive loads in the industry? How are we going to invest to be able to drive even homes? How are we going to invest to drive loads commercially? This is the main reason for this study. Thank you.
Thank you so much, sir, for your time. So do you have any questions?
I have only one question. Thank you for the presentation. The graphics and the results that you are presenting here was simulated in MATLAB, or have you measured the motors and you?
It was simulated in MATLAB.
Okay, thank you.
So what I have measured, yeah.
Yeah, I understood that. It's only a clarification for me. Thank you.
Thank you so much. So we'll be moving on to the next presentation. We have our next presenter who has a paper titled on dimensional reduction to improve learning recommender systems precision based on goals. Are you there, sir?
Yes, I'm here. Can you hear me?
Yes, sir, we can hear you. You may start with your presentation.
Okay, thank you.
Yes, sir, your screen is visible. You can start.
Perfect. I'm delighted to be here today to share with you some insights into recommender system applications. My name is Rodolfo, and over the past 5 years, I had the privilege of working with academic data for Salesian Technical University. I am lecturer in the computer science department, and I represent the research group on artificial intelligence for education. Today, I'll be diving into dimensional reduction techniques for learning recommender systems. In this sense, this presentation is a case study of the application of recommender system over academic data. Okay, then I'd like to begin. I divide my presentation into 5 sections. The first one is the introduction, where I explain the importance of recommender system for education. The second one is explanation of matrix factorization and its importance. The third section is the methodology, where I want to explain each stage of the process. The next section is results, where I expose the main points of this research. And finally, section 5, it's about conclusions. In higher education curricula worldwide, the option to take elective courses exists. However, students encounter the issue commonly referred to as information overload. Thus, the question arises, how does one select an elective course that aligns with their needs? Nowadays, students enroll in several optional subjects during their course career in different knowledge areas like humanities, arts, sciences, technology, or simply complementary courses. Even some universities offer a wide catalog of massive online open courses with the possibility to confer course credit. The catalog is wide, and the chance to explore new academic fields should be an opportunity for each student. In this context, we propose a learning recommendation system considering the academic data nature, which is majority is dispersed. Our experience allows us to detect the similarities between movie datasets and datasets of academic grades. The first one stores the ratings of a user over a movie, and the second one stores the grades of a student over a subject, both with a high sparsity levels. Our approach draws from this data and regards that the student passes successfully a subject and subject was useful for its science. The subject does not have a score-based rating to determine likes or dislikes, and the evaluation process of the course are anonymous. A challenge encountered by recommender system is the issue of data sparsity, given that not all students undertake every available course, resulting in a sparse matrix. To surmount these challenges, the study advocates for the application of dimensional reduction techniques, which serve to transform the sparse matrix into a more condensed yet informative representation. This reduction augments the predictive efficacy and versatility of employing a spectrum of machine learning techniques. Machine learning techniques have a lot of problems with sparse matrices. The matrix factorization model emerged as the preeminent choice in contemporary recommender systems. The figure allows us to appreciate that the intention is to move from extensive datasets to reduce datasets that condense the majority of the system information. Now, we've already detailed the main techniques of matrix factorization. Single value decomposition, where the user-written interaction are modeled as inner products in a combined relative factor space of dimensionality F, which include both users and items. SBD++. This model uses extra information by taking into account implicit feedback, which offers an extra hint of the user preference and prediction accuracy is increased. Matrix factorization is one of the current recommender system most frequently uses. Non-negative matrix factorization is a recent variation of classical matrix factorization. Non-negative matrix factorization was initially presented and made widely known as low-rank matrix approximation method. Finally, Bayesian matrix factorization is a new approach in recommender system for car clustering. To establish the methodology, we begin with the input dataset. In our case, we are working with a dataset from Salesian Technical University, which collected information over 5 years from 1,000 courses that can be taken by 10,000 students. In this dataset, the data dispersion level is 70%, which is excellent, considering that the majority of recommendation systems deal with dispersion levels of 99%. The dataset was divided into 5-fold for cross-validation. With the training dataset, the computation of the two matrices enabled matrix factorization was performed. In our case, classic matrix factorization, non-negative matrix factorization, and Bayesian matrix factorization were applied. Finally, to compare the results, the key nearest neighbors algorithm was implemented as a classical prediction technique using collaborative filtering. The purpose of this is to demonstrate that matrix factorization techniques achieve excellent results compared to classic collaborative filtering techniques. The quality metrics employed in this study were the mean absolute error and precision. These two metrics enable us to conduct the aforementioned comparison between matrix factorization techniques and classical collaborative filtering techniques. To present the result, it's important to mention that a key hyperparameter is the number of factors utilized in matrix factorization. In this regard, we rely on literature and various studies which agree that the optimal value is k equals to 6. In this slide, we can appreciate the different baseline methods that were utilized. The summary table clearly indicates the superiority of matrix factorization models, especially the Bayesian matrix factorization model. This reaffirms our initial hypothesis that matrix factorization can perform very well with academic data, which is inherently sparse. In the case of collaborative filtering, experiments were conducted to determine the mean absolute error from 2 neighbors to 10 neighbors. For comparison, the number of neighbors that produced the best mean absolute error was selected. In this case, k equals to 5. Finally, we can summarize the presentation with 2 important conclusions. Dimensional reduction is an important technique to enhance prediction quality, addressing the challenge of data sparsity in recommender systems. Matrix factorization techniques prove to be more accurate with Bayesian matrix factorization, achieving noticeable precision. Do you have any questions?
Thank you so much, sir. Do you have any questions, sir?
Hi, Rodolfo.
Hi.
Yeah. If I didn't miss anything, the database that you used on this on your research was based on decisions that students made in last years about which courses or classes they intend to enroll. Is that correct?
Yes, we use the grades obtained by students.
Okay. Have you measured the real results using your recommendation system and what the students really chose for enroll? Have you ever measured that, or this is the first step that you are planning to do? The next step, sorry.
We use the grades because we don't have feedback from students. If
Okay.
a student approve the course, we assume this is a like. If the student don't approve, this is a dislike. Very similar to data sets on movies. We don't have stars in this in our data sets.
Okay. Okay, no, I understand that. Okay, thank you.
Thank you so much, sir, for your presentation. So we'll be moving on to the next presentation. Next up, we have Renata to present her paper titled Privacy Measures at HEI in Republic of Korea.
Hello.
Are you there, ma'am?
Yes, I am. Do you hear me?
Yeah, we can hear you. Maybe start with the presentation, please.
Okay, but I cannot share the screen.
Are you able to share the screen now, ma'am?
Yes, I can now.
Sure.
Okay, so I'm Renata Mekovic from the Faculty of Organization Informatics, University of Zagreb from Croatia. I will present the paper that my colleague Maria Kuštaleka and myself prepared for this conference. So rapid technological developments have brought new challenges for the protection of personal data. There has been a dramatic expansion in the scope of data collection and exchange. The public increasingly says they don't know what companies are doing with their data. But on the other hand, people understand that companies rely on their data in order to provide personalized service or products. Higher education institutions collect data about their students. The collection of such information should be of interest to higher education institutions in order to improve the teaching process, but also to influence the students' learning. Data on exams during the certain year, grade average duration of studies are information that are required to be collected by law. However, more and more institutions are switching to information and communication technology supported teaching strategies. In this way, it is possible to monitor other information about the student, such as the time of joining a specific e-course, the time he spent in a certain activity, the method of solving the specific task, or the results of particular activity. A wide number of education delivery solutions are based on digital technologies that have learning analytics features built in. The field of learning analytics has continued to expand, but the main goal of measuring, collecting, analyzing, and reporting data about learners and their contents to understand and optimize learning and its environment remains the same. With the help of learning analytics, institutions can more precisely identify students who are at risk of dropping out, detect learning gaps, and observe online students' activity in collaborative tasks. All previously mentioned improvements have made it possible to track and record every interaction and use of the particular resource, for example, Moodle, are raising concerns over the data security. Understanding students' privacy concerns can increase the performance of learning analytics tools in higher education institutions. The findings mostly demonstrated that learning analytics increased students' motivation and improved their learning approach. But as far as students' privacy is concerned, not much research has been done. The aim of this paper is to examine how much higher education institutions in the Republic of Croatia are oriented to protect students' privacy. We stated 2 research questions. First question is, what organizational and technical measures have institutions taken to protect the data they collect about students? And the second question is, what is the institution awareness of possible technologies that can be used for teaching, such as services based on Internet of Things systems? The methodology that we used as followed the case study process in 6 stages: plan, design, preparation, collection, analysis, and sharing. A total of 6 universities and 6 faculties in the field of information and communication or computer science were included in the sample in order to provide an extensive and comprehensive description of how higher education in Croatia approached the protection of students' rights and to what extent they comply to privacy principles. This methodology is based on multiple case studies in which each of the individual cases were selected according to the principle of similarity, such as dealing with the scientific field related to information and communication sciences, assuming that these faculties will have approximately similar results without large deviation and extremes. We searched for documents that were publicly available on the institution websites, such as privacy policy, privacy regulation, security policy, and forms for exercising the rights of individuals. Furthermore, we looked for instruction on practices of personal data handling that institutions have prepared for their employees, researchers, and students. We monitor the practice related to the type and amount of personal data that institutions publish on their websites. Our focus was on organizational and technical measures taken by institutions to protect the data they collect about students. In order to define criteria for inspection, how much higher education institutions in the Republic of Croatia are oriented toward the protection of student privacy, we used General Data Protection Regulation, Data Act, and ISO 29100/2011. Here are listed criteria for organizational measure, criteria for technical measure, and criteria for services based on Internet of Things systems. The results were analyzed using the cross-case analysis research method. This method is used to systematically compare small samples of cases in order to observe similarities and differences that will later contribute to better understanding of the pattern. For this purpose, cross-case variables were developed in terms of criteria according to which further analysis will take place. The defined criteria were applied to each individual case, where instances could receive one of the following ratings: no, does not meet the criteria at all, partially meets some aspect of criteria, and yes, fully meets the criteria. The criteria related to services based on Internet of Things system from Data Act showed that none of the analyzed universities or faculties are using connected products or related services for teaching. Here are results of analysis at the university level. There are 6 universities included in analysis. Research results at university level are poor. Only 2 universities out of 6 fully meet the criteria related to organizational measures. Organizational measures refer to how institutions inform individuals about the ways in which they will collect, proceed, share, and destroy their personal data. Technical measures refer to methods by which institutions ensure the rights of individuals. For example, how the right to restrict the use of data is exercised. The results related to technical measures are worse than the results related to organizational measures. Only for criteria 7, we have 2 universities that meet that criteria, while for criteria 8, we have 3 universities that meet it. Here are results for organizational measures at the faculty level. It can be seen from the graphic representation that the results are worse. Only 1 faculty meets all the criteria. 3 of them partially meet the criteria, while 2 do not meet the criteria at all. Here are results of analysis regarding technical measure at the level at faculty. Results are even worse than those on the university level. So, for conclusion, criteria that are unmet are related to technical principles for maintaining accountability and information security. Universities lack a risk management strategy in which risks are evaluated and preventive measures are implemented. Little is being done in terms of information security in regards of physical and technical protection against unauthorized access, data leaks, and other privacy violations. The results at the faculty level are worse than those at the university level. Some institutions may not even have a document outlining their privacy policies. To conclude, through summative analysis, we can define certain guidelines for improving the protection of students' privacy. Some of guidelines include: ensure easy accessibility and visibility of privacy policies. On the website, provide detailed information about principles, collection, and processing of the data. Provide documents, templates, and forms to facilitate the exercise of the certain right. And when publishing information about students, best practice include that this information should be informed in summative list and include a minimum of basic information about the student. So these are results of our study. Thank you for your attention, and I will gladly answer all your questions if you have.
Thank you so much, ma'am. Sir, do you have any questions?
I did not have any questions, but it's some quite annoying to know that some privacy information are not so secured as we think about. Thank you for sharing that, Renata. Thank you.
Thank you very much.
Thank you so much, ma'am. So we'll be proceeding with the next presentation. Next up, we have Marcella presenting the paper titled Software Defect Prediction, a machine learning approach with voting assembly. Are you there, ma'am?
Yes, I will share the presentation.
Okay, ma'am, you may share your presentation.
I cannot share.
You cannot share the presentation now? Yeah, we can see. We can see your presentation, ma'am.
Can you see only the presentation?
Yes, ma'am, we can see your presentation. You may start with it.
Okay. Hi, everyone. I'm Marcela. I'm present a paper entitled Software Defect Prediction, a Machine Learning Approach with Voting Ensemble. The content we are going to review is an introduction, aim, methodology, conclusions, and reference. Software defects commonly refers to as bugs or anomalies or discrepancy within a software system that lead to deviation from intent functionality or performance. These defects can arise from a multitude of sources, like errors in coding, design flaws, incorrect requirements, elicitation process. The identification and rectification of software defects are crucial for ensuring the reliability, efficiency, and overall quality of the software. The goal of software testing is to verify whether a program performs its intended functions and to identify and correct defects prior to deployment. Binary classification. A fundamental aspect of machine learning consists of classifying software components into two groups, defective or non-defective. This method of classification harnesses the power of machine learning to efficiently analyze complex data patterns, enhancing the accuracy of defect predictions. Supervised learning algorithms, including k-nearest neighbors, KNN, and support vector machine, SVM, have demonstrated significant potential in accurately predict software defects. This study presents an approach using a machine learning framework with a voting ensemble model using KNN and SVM for software defect prediction. The aim of our research is to enhance the performance of software defect predictions models by addressing the challenge of imbalanced datasets, which is a common issue in the fields of software defect prediction. Figure 1 presents the method composed of three phases based on the CRISP-DM methodology. For the first phase, the dataset JM1 was taken from Promise Software Engineering Repository. This dataset have 21 independent variables corresponding to software metrics, including 5 different measures of lines of code, 3 Maccabi metrics, 4 hasted basic measures, 8 hasted derived measures, and a branch count. The dataset was transformed, the dependent variable binarized to reflect Boolean categories, because this is crucial for binary classification model application. To counter missing values, a mode replacement strategy was adopted, mitigating their analytical impact and maintaining dataset integrity. The strategy for missing values is the substitution with the median. In this context, the depend variable is defective. A Boolean variable indicates whether a software module contains defects or not. An exploratory data analysis was conducted examining class frequency in the dependent variable. This is essential for evaluating dataset balance. The total number of instances is 10,885, of which 9.3% correspond to defective models and 8.7% to non-defective models. For the second phase, two predictive methods have been trained and optimized by adjusting the parameters of each of them. The final optimization parameters are present in Table 2. These parameters were used to obtain a voting classifier combining KNN and SVM with the best parameters for each of them. And for the second phase, to address the imbalance in the data, a specific strategy were adopted. These strategies are present in Table 3. These include the use of oversampling and subsampling techniques. This was complemented by the implementation of more sophisticated techniques such as mode and domain links to further refine the distribution of class. Various training data sets were generated to predefine voting ensemble. For the third phase, we examine a set of 2,170 modules and successfully classified 1,716 modules as non-defective. This represents a high percentage of true negatives. This indicates a significant effectiveness of the model in identifying non-defective modules. On the other hand, 410 defective modules were erroneously categorized as non-defective. This is a considerable number of false negatives. In turn, only 36 defective modules were correctly identified, making them as true positive. Now we can see this pattern in the results suggests that while the model is efficient in recognizing non-defective modules, its ability to detect defective modules needs to be improved. In datasets where one class predominates, in this case, modules without defects, machine learning models may exhibit a bias toward the majority class, resulting in accurate identification of those cases, but often at the expense of accurately classifying the minority class, in this case, defective modules. This dataset imbalance potentially leads to reduced sensitivity to defective modules, evident in the elevated number of false negatives. While the model demonstrates efficiency in recognizing non-defective modules, its ability to detect defective modules was compromised. Table 4 presents the results of applying the ensemble model after each one of the techniques for imbalanced data. Now we can see significant change in the detection of defective modules. This is class 1. First, the recall. In class 1, the recall has increased from 8 to 48. The model can now detect a higher percentage of defective modules than before. This is particularly crucial in scenarios where minimized false negatives is essential, such in a quality control or critical fault detection context. Precision has decreased from 71 to 39%, but this change should be considered alongside a notable improvement in recall. The initial low precision may have been to the model infrequently predicting a model as defective, resulting in a small number of positive predictions with high precision. Data balancing has prompted the model to identify more cases as defective, reducing the precision by crucially preventing the omission of actual defective models. Class 1 F1 scores has risen from 14 to 43%. This balanced model demonstrates enhanced overall performance in identifying defective modules, showcase a more effective balance between precision and recall in his harmonic average. Finally, the conclusion of our work. The use of techniques such as balance debugging classify has addressed the inherent balance in the data, which initially led to a bias toward the majority class, non-defective models. Balancing the data has significantly improved the recall for the minority class, indicating an increased sensitivity of the model to defective models. Accurate identification of defective models is crucial, especially in high-stakes environments like safety-critical systems where defects can lead to severe outcomes. Prioritize increased recalls of defects, even if it reduces precision, is beneficial in situations where missing actual defects is unacceptable. This strategy is vital for minimizing risks and guaranteeing the quality of the software. The analysis has shown a balance between precision and recall, especially after applying class balancing techniques. While the precision for the detection of defective module decreased, the increase of the recall of this class is a significant improvement, reflecting a more sensitive model capable of identifying critical cases. This balance is crucial in informed decision-making in practice, where a middle ground must be found between avoid false positives and not overlook false negatives. Finally, I present the reference for our work, and thank you.
Thank you so much, ma'am, for your presentation. Sir, do you have any questions?
I have only one question. I understood that you apply this technique in only in one software. Is that correct?
Yes, I
Only
use
database that you showed is this Promise Software Engineer repository.
Yes, this dataset is very used for machine learning in a context of software. Is available in the reference.
Fantastic. Have you tried this same technique on other dataset?
The repository have many datasets, but no, I not prove this technique which other datasets. But
Okay.
maybe there is a future work in this way.
Okay, thank you. I already I had one work using detection on pipeline and build systems, so I was interested in use data set to analyze things on this kind of on this matter. So thank you for your presentation and the explanation about the data set.
Thank you.
Thank you so much, ma'am. So we'll be moving on to the next presentation. And next we have Mohammed Shahzad with us to present his paper titled Software Test Case Minimization Using Modified Firefly Technique. Are you there, sir?
Yes, I am.
Okay, you may please start your presentation, sir.
Thank you.
Yes, sir, your presentation is visible. You can start.
Okay. Assalamualaikum. Good afternoon, good evening, and good morning, distinguished guests and fellow researchers. My name is Mohammad Shahzad Ali Shobut from Joshua University of Science and Technology, Bangladesh, and I am delighted to be here today at the 9th International Congress on Information and Communication Technology Conference. In my research, I will conclude these topics: introduction, state of the art, methodology, result, and conclusion. First, introduction. In a rapidly evolving digital landscape, the importance of robust testing methodologies cannot be overstated. As we navigate the complexities of modern software systems, the quest for effective testing strategies becomes even more crucial. Throughout this conference, we will explore the latest advancement and best practices in software testing, aiming to enhance the reliability and quality of software products. Our research is based on three criteria that are software testing, model-based testing, and Firefly algorithm. The practice of assessing and confirming that a software program or product performs as intended is known as software testing. And in model-based testing, the functional characteristics of the system being tested are described by a model from which the test cases are produced. And then Firefly algorithm. Using the Firefly method on the input data, we will extract the substring representing the base solutions. The test case suite will be reduced by using this substance. We have also built the model using 4 different criteria that are data flow, control flow, state transition machines, and decision tables. Software testing usually takes a lot more time and resource than developing the actual product. It is a stage that slows down the development and does add actual value to the product. The algorithm we used will pick the test cases that provides most coverage. This way, a few test cases could traverse the whole system. So executing the same paths will be minimized. And next, we will have current state of the art. Here we have traversed through some esteemed works. We have done research on test case minimizing strategies. The main goal of this research is to optimizing and minimizing software test cases to save time and resources with maximum accuracy. There are very few articles published on this topic though, and the most of them are written well before 2015. Here, Shiva's et al. Worked on convolution network and assessed 99.32% accuracy at fault detection. And Noor Laili worked on Firefly algorithm and they have reduced 31% test paths. And Andres Lichtner worked on slicing technique and decreased test cases by 95%. Ahmad Saifan worked on data mining and they reduced almost 80%. Rashmi Gupta worked on coverage-based technique and they have used synthetic data set and they have reduced 40% of test case rate. And at last, Ditya Taneza, who used hybrid model and produces minimal test case suite company similar studies. Okay, the objectives, the goal is to find out the test cases with most coverage and to rank them accordingly to fitness function. The scope of our research is picking out the optimal test cases from the test suite, and the limitations are the approach. This approach doesn't deal with testing automation and it does not deal with test case generation. And therefore, we'll go into methodology section. In our research, we used Firefly algorithm, which is a meta-heuristical algorithm. Meta-heuristical algorithm are approximately sorry, meta-heuristical algorithms are approximate solution method for an optimization problem that use a randomness property with an educated guess in their search mechanism. They try to improve their quality of the solution at hand through the iterations from a randomly generated set of feasible solutions by exploring and exploiting the solution space. Even though these algorithms do not guarantee optimality, they are tested to give a reasonable and acceptable solution. In this research, we have used a Firefly algorithm. In the algorithm, a randomly generated feasible solution called Fireflies will be assigned with a light intensity based on their performance in the objective function. This intensity will be used to compute the brightness of the firefly, which is directly proportional to its light intensity. For minimization problems, a solution with the smallest functional value will be assigned with the highest light intensity. Once the intensity or brightness of the solutions is assigned, each firefly will follow fireflies with better light intensity. The brightest firefly will perform a local search by randomly moving in its neighborhood. In this section, we have demonstrated a dummy graph which represents a simplified dummy minimization problem in which there are just two input values. We take the two fireflies x and y, and the global minimum value is at x equals 0 and y equals 0. If we want to understand the firefly algorithm, the basic idea of firefly algorithm is that a firefly will be attracted to any other firefly that has a higher intensity, and that attractiveness is stronger if the distance between the two fireflies is smaller. So firefly 0 has the highest intensity and will not move. We take this, and Firefly 1 and Firefly 2 will both be attracted to and move forward Firefly 0 because Firefly 0 has the highest intensity. Because Firefly 1 is closer than Firefly 2 to Firefly 0, Firefly 1 will move a greater distance than Firefly 2. Application of our research is each Firefly has a partial position that represents a possible solution to the minimization problem. More fireflies increase the chance of finding the true optimal solution at the expense of performance. Here we take a sample data, which is synthetic data, and this data is from a system called ATM, automated teller machine. And these are the test paths we have generated. All data are synthetic in your research. And we have created adjacency matrix from the given system from the data. And from the input path, the simple adjacency matrix will be made of the whole graph. This adjacency matrix will be used as base matrix to generate guidance matrix. Use of adjacency matrix, it represents the total graph from the given test path. In this section, we have used cyclomatic complexity to compute the control flow graph of the program. The general formula for cyclomatic complexity is E for edges, V vertices, and plus 2. And therefore, we used a formula for guidance factor, which is 10 cc into vertices minus iteration minus 0.1. And used those formulas, we calculated the uh, guidance matrix actually. And the path extraction algorithm is we take the first non-zero minimum value from the first row. If all row elements are 0, we will go to the next row, set the row and column. And if we take a non-zero value, we see which row it's seated, and we will go the next column. And if the value is 1000 or the elements have become 0, we will start again. And there is the extracted paths from the given system we get, and these are the substrings, and we will match these substrings to our given path to minimize test paths. In this section, we have used Needleman-Wunsch algorithm to rank the similar paths. When there are multiple matches, we will match those paths against the match sequence to rank them accordingly. Here there were 7 or 8 paths, and we have tried to minimize 2 paths. The goal is simple substring match. Pick the test path that has direct substring match. Chosen test paths usually have high coverage. We will move forward to evaluate the paths, and these selected paths have high coverage. As you can see that all state is 100%, all transition is 100%, and all the pairs, transition pairs, and loop paths are 100% covered. And there are some issues in this research. The first major issue is to define the intensity of a firefly.
Sorry to interrupt, sir, but you have 2 minutes to conclude the presentation.
All right. Okay. Firefly algorithm is materialistic. You are free to define intensity however you like, as long as a higher intensity is associated with a better solution. The next major issue is to define attraction so that closer fireflies will move toward a more intense target more than distant fireflies will move. And in this result section, in the primary sample case, the test suite was reduced by 36.17% while ensuring 100% coverage from the selected cases. Ranking them according to would make execution faster as it eliminates similar matches. Further data testing and analysis are required for this to use this test. We have surveyed, we have wrote a survey paper as a part of the literature study and preparation for this research, which has been published on October 24, 2022 in the 2022 14th International Conference on Contemporary Computing under ICPC in FM Digital Library. This analysis explores general methods for test case reduction and specifically focuses on those applied to a email state cert. The emphasis lies in detailing the algorithms used and the execution of test case minimization, providing procedures, equations, and sample data to illustrate the suggested approach. The proposed minimization strategy effectively covers additional test coverage types while reducing the overall number of test cases. Due to resource and time constraint, this work introduces a firefly-based method for optimizing and prioritizing test routes using UML activity diagram. The strategy prioritizes test pathways based on psychometric complexity and guidance metrics, and utilizing the adjacency measure of the activity graph flow graph. The broader effort aims to establish a framework for UML state chart test case creation with future work evaluating comparable techniques for test coverage and minimization levels. Thank you. If you have any question, you can ask now.
Thank you so much, sir. Sir, do you have any questions?
I'm a little bit curious about only the execution of the tests. You have mentioned that was not automated generated or even it was not automated, but I'm a little bit confusing about that. The result that you showed here was really applied on such a repository or software, or is only a comparison, is only compared to some data set or database that shows only the test case.
Yeah, it's just compared to data set actually. We have not yet applied to any system. We used some synthetic data set which was produced by artificial intelligence, and we used some data sets from the existing system to test those systems. So,
Thank you. It's very interesting the result that you showed here. That's why I'm asking this question. Thank you so much.
thank you.
Thank you so much, sir, for your presentation.
You are welcome. Thank you.
So, okay. So now I sincerely thank our authors for their excellent presentations and contribution to the session, and all our participants for being a part of this international conference. I hope this session was informative enough for you. We, on the behalf of the whole team, thank you for your support during this 9th version of the conference and all the previous 8 versions of the conference. We will be happy to have you at the 10th version in 2025 as well. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to Springer. The publication will be live within 6 months. So kindly cooperate with the team of ICICT 2024. I would also like to thank our session chair, Professor Kelly, for sessioning this chair, for chairing the session. Sir, this is a token of love and appreciation on the behalf of the team of ICICT 2024 and Global Knowledge Research Foundation and partners. Would you like to share a quick closing remark, sir?
Thank you again for the invitation. It was a very pleasure to be here and to talk to all the authors and the high level of the papers and the presentation here. Thank you again. I'll be looking forward for the papers and the lecture notes on the Springer repository, because some of those I'm really sure to be used here in Brazil for with my students. Thank you again.
Thank you so much, sir, for your valuable presence. I would like everyone to open their camera once for a quick snapshot before we end this session. Yeah, everyone, please. Thank you. I'll take a picture. Thank you so much, everyone, for your valuable presence.